Because the performance of a Firestop system in an actual fire is largely dependent upon how it's installed, inspections of completed work have become an effective tool in ensuring life safety compliance. Proper inspection, however, requires more than simply ensuring that the Firestop is present. Authorities having jurisdiction have been performing thorough inspections on Firestop in new construction for more than a decade. But because this level of scrutiny is rare on work performed in existing facilities, a chronic problem of missing or improperly installed Firestop has become widespread. It seems unfortunate that inspections are even needed, but the reality is that too many untrained people are expected to do Firestopping. When inspections reveal deficiencies, however, and you hold up your payment to vendors and contractors, the message quickly becomes clear and standards begin to rise. The purpose of this tape is to help provide proper inspection practices as a tool to raise the performance standards of installed Firestop systems. If you ask the average trade person how to inspect Firestop, you will likely be told simply make sure that the penetrations are sealed with red caulk and that there is a UL logo on the tube. Unfortunately, this would confirm little more than red caulk is present, which really tells you nothing for several reasons. First, caulk alone is often not enough. Other accessories are sometimes needed, such as collars, wrap strip, mineral wool, or aluminum foil tape. If all you were looking for was red caulk, and these items were required, an improper installation might inadvertently pass inspection. Likewise, there are many legitimate Firestop sealants that are not red. So rejecting an installation on the basis of color is simply inappropriate. Finally, there are a host of other parameters to consider that are overlooked by simply inspecting color. These factors are all detailed in the UL system information and include such things as making sure the sealant is installed to the proper depth, the hourly rating of the UL system matches the rating of the barrier, and making sure that the product is tested for the type of penetration in the barrier. So how do you know if a given installation is properly installed? In fact, the only way to be absolutely sure is to perform a destructive inspection. But since cutting out every installation is impractical, let's review how this can be better accomplished. The first step is to ask the installer for a copy of the UL system that was or should have been followed during the installation. Now, the UL system clearly spells out how to install the product, what can be done and what can't be done. It's a roadmap. And if he or she can't produce it or doesn't understand what you're asking for, well, it's best to simply reject their work without going any further. This is done for two reasons. First, if they installed the product without a roadmap, well, chances of a compliant installation are rare, and there's no point in wasting any more of your time. Secondly, this sends a very clear message about what's expected. People are smart and learn quickly, and when the time comes to reinspect later, well, chances are they'll be better prepared. If they can produce a UL system for each installation that you choose to inspect, then these are the steps that should be followed. First, confirm that the barrier type matches the system. If the drawing you were given is for a concrete block wall, but you are looking at a gypsum wall, there's a problem, and the installation should be rejected. If the opening in the barrier is a construction joint, the additional step of confirming whether or not the joint is static or dynamic is necessary. If you're unsure whether or not the joint moves, either check with a professional engineer or err on the more conservative side and assume that it's dynamic. A UL system that's tested in a dynamic condition may be used in either joint condition, but a static tested UL system may only be used in joints that don't move. Likewise, if you have a 3-hour barrier but are handed a 2-hour UL system, there's also a problem. Whenever examining wall penetrations, be very careful of the hourly ratings. In concrete walls, a system with a 2-hour rating includes coverage for 1-hour walls as well. But in gypsum wallboard walls, a system that only says 2 hours doesn't include coverage for 1-hour walls. Now, if it says 1 and 2 hours, then of course it can be used in either. Now, While these seem like nitpicking details, they're published this way for a reason. A system that may work in a 2-hour gypsum wall may actually fail in a 1-hour wall because there's one less layer of wallboard available to recess the sealant into. If everything checks out, then proceed to confirming the penetration type. Otherwise, the installation should be rejected. If the barrier type, rating, and hole parameters all match the requirements of the UL system, then the next thing to check is the penetrating item itself. First, identify what it is: pipe, conduit, duct, cable tray. Next, confirm what it's made from: steel, copper, aluminum, PVC, polypropylene, and so on.
Then determine what the trade size is. Pipes and conduit are easy, but cable tray and HVAC duct should be measured.
For HVAC ducts, note if the dimension is round, flat oval, or rectangular. Note also the gauge of steel used and whether or not a damper is present. Then, for insulated duct or pipe, determine what type of insulation it is and how thick it is. Be sure to reseal any penetrations you make in the installation during inspection. If it is combustible pipe, you need to know if it is vented or closed, as they are sometimes Firestop differently. This is because vented plastic pipe, such as DWV or acid waste lines, burn rapidly as oxygen is pulled in to feed the fire, while closed plastic pipe, such as RO or deionized water lines, burn somewhat less aggressively. For bundled cable, measure the maximum diameter of the bundle and note what type of cables they are. For trays, note whether it is steel or aluminum, open ladder or center hung. Then calculate the cable load and measure the maximum depth of cables in the tray. If the penetrating item is routed through a sleeve, note this too. As you run down the checklist in the UL system, it will quickly become obvious whether or not the proper system was provided. If not, the installation should be rejected. Whether the condition is a joint, a blank opening, or a through penetration, the next step is to confirm the size and shape of the hole. For blank openings, the UL system will list the maximum size. If the actual hole is larger than this, there's a problem. In linear applications, be sure to confirm that the width of the actual construction joint does not exceed the largest permitted width in the UL system. When the opening contains one or more penetrating items, the process is similar, but we have the additional step of measuring the annular space, or the distance from the outer diameter of the penetrating item to the inner diameter of the hole. The annular space is a significantly limiting factor for Firestop systems because the larger it gets, the harder it is for the sealant to do its job. An excessively large annular space may require additional measures such as adding more mineral wool to prevent the sealant from blowing out in a real fire. The UL system limits the annular space to some specified minimum and maximum in inches. Both the upper and lower limits tend to vary quite a bit from one system to another. Because pipes are rarely centered perfectly in the middle of a hole, many recent UL systems have been tested to permit the penetrating item to be off-center, and in some cases even touching one side of the opening. This condition should raise a flag, since you would now have both point contact and an excessively large annular space on the opposite side. Look for this and accept only installations that have been installed as tested. On non-combustible pipe, it's not uncommon to see the UL system permit point contact or zero annular space. Continuous point contact is where the penetrating item has no annular space at all and is touching the opening on all 360 degrees. An example of this is when gypsum board is cut to fit tightly around a pipe. If that pipe is a sprinkler pipe and penetrates fire barriers, structural walls, and certain other kinds of assemblies, take additional care as NFPA 13 mandates very specific annular space requirements. If the sprinkler pipe is 3.5 inches or less, there is a 1-inch minimum required annulus, while larger pipes are required to have no less than a 2-inch nominal annular space. When the penetrating item is combustible, the UL system often requires a minimum annular space of some amount. This is very important, as it allows enough space for the intumescent material to be inserted into the hole, permitting it to expand and close off the combustible item. Now, if too little intumescent material is used, the Firestop system may not work as designed. If the annular space in the as-built condition falls outside the parameters permitted in the UL system, it must be rejected. Another annular space condition that merits special attention is around grouped penetrations. If the annular space measurements fall within specified tolerances, then proceed to confirming the Firestop materials themselves. There is a popular term in Firestop jargon known as caulk and walk, which refers to UL systems that require nothing more than Firestop sealant. If the system being inspected is one of these, then your job's very easy. There are two things to check: the bond and the depth of the sealant. When confirming the bond, make sure that the seal is well adhered to both the barrier and the penetrating item. Because it can be difficult to get a caulk gun all 360 degrees around a pipe when working in a confined space, pay close attention to the top of the seal around 12 o'clock. It is amazingly common to find penetrations with the top section unsealed, which clearly must be continuous. Confirming the sealant depth requires destructive inspection and is simply a matter of cutting out a section of Firestop, which might be caulk, putty, mortar, or spray, and measuring it to compare against the minimum depth specified in the UL system. Achieving the proper sealant depth is especially critical on combustibles such as plastic pipe, cable bundles, and insulated pipe. Most UL systems, however, are not the caulk and walk variety and require more than just Firestop sealant. They often require the use of an assortment of accessories and additional Firestop products, such as collars, wrap strip, and mortar. When multiple products are used in one opening, make sure that they are manufactured by the same company, as required in the UL system. Mixing Firestop products from different manufacturers voids all warranties and places an unnecessary burden of liability on the installer. The most common accessory is mineral wool, but depending on the system, other items such as foil tape, angle iron, fasteners, hose clamps, and backer rod may be required as well. The exact requirements are detailed within the UL system directory. When packing material, such as mineral wool, is required, it is an integral part of the UL system, and inspecting it is just as important as inspecting the sealant itself. If the requirements specify 3 inches of mineral wool, this is the minimum allowable depth and should be confirmed. When a Firestop collar is anchored around a combustible pipe, make certain that the tabs are securely closed, the correct fasteners are present and well anchored. This will help ensure that the collar doesn't burst apart or fall off the assembly while expanding during a fire. When wrap strip is used, take special care to read how many layers are needed. Some systems require up to 10 layers of wrap strip, and if less is used, the system is non-compliant and should be rejected. The restricting metal shell that encapsulates the wrap should be well anchored to the fire barrier, like the collars, and require either screws or hose clamps, depending on pipe size. Like sealant, Firestop mortar must also be installed to a minimum depth, although much deeper,
usually around 4.5 inches. The depth of mortar can be inspected non-destructively if you know how thick the wall or slab is. Measuring the recess and subtracting it from the barrier thickness yields the mortar depth.
When inspecting joints, the same principles apply. There is usually packing material, such as mineral wool or backer rod, that has been compressed to a certain specified amount and then covered with either a thin film of spray or caulked with a bead of sealant. A simple destructive inspection will reveal if the seal and packing material has been installed to the proper parameters. Because the complicated nature of pillow installation is addressed in depth in the fit high-traffic openings, it will not be covered here. Please refer to that video for additional information about proper pillow installation. When inspecting Firestop, it would be extreme to go to this level of scrutiny for every condition, and yet destructive inspections are the only way to be absolutely certain that an installation is truly acceptable. So, are inspections even useful? Well, the answer is yes when used properly. Human nature works to your advantage. because when people know they're being watched, their work tends to improve. Now, this is easily accomplished by establishing a consistent policy of checking a small number of random penetrations for all installers. If you're familiar with the installer's work, it should be obvious what level of inspection is needed based on their track record. If you don't know someone's work, performing destructive inspections on a few random installations will quickly give you a sense of whether or not the installer knows what he or she is doing. Even though a majority of the installers strive to meet the UL standards, the knowledge that their work is to be randomly inspected is just another incentive to help ensure that the proper systems are being used and that they are properly installed. The most effective way is to start by randomly selecting a number of conditions and performing destructive inspections. If it is a small job, start with a few. If one is wrong, check 3 more. If rejected installations accumulate, it will become painfully obvious to the installer that there is a serious problem, and you will likely find little resistance in rejecting the whole job. On a large job with hundreds of penetrations, select a small percentage of the total, such as a few in each room. For each one that you find that is wrong, inspect several more. You will quickly get an idea if 1 or 2 isolated cases were improperly sealed, or if these rejected installations are symptoms of a much larger problem. If you have no confidence in their ability to remedially correct their work, you might consider back-charging them and paying someone with proven skills to finish the work properly. If a pattern of unacceptable work emerged from one job to the next, you may also consider back-charging them for excessive inspection time. Now, by following a formal and consistent inspection process, all workers sealing penetrations in your building will begin to realize that standards must rise or their work will be rejected and they may not be hired back. The best tool for helping to reduce the amount of time spent inspecting Firestop installations is standardization. The UL Fire Resistance Directory contains over 2,000 systems in total, most of which are redundant. If you can standardize around the fewest number possible, you can radically simplify the inspection process. For example, it would be easy to standardize every sleeved opening in gypsum board walls full of Category 5 cable bundles around the requirements of one specific UL system. Before long, you'll have the UL system requirements memorized, and all of these sleeves will start to look the same, reducing the inspection time. Considering that each craft in your facility may need only a half a dozen systems to cover 99% of their applications, you can reduce the thousands of potential systems in the UL Fire Resistance Directory down to a manageable number. In the end, it's impractical to expect inspections to provide absolute confirmation that all Firestop installations are performed properly. Inspections, nonetheless, are a powerful tool not only in assuring compliance, but in communicating your expectations and raising the standards of Firestop installation overall. If installers know that no exceptions will be tolerated at your facility, they'll work even harder to make sure all of their work will pass inspection. A clearly stated inspection policy ensures better work, less time spent inspecting and repairing seals, and helps ensure compliance.